It's just a friendly reminder that like our video. And don't forget to subscribe for next free videos at ThunderEDUC.
The effect of increasing in the concentration of the reactant. So if you increase the concentration of the reactant, it means that you're increasing the reacting particles per unit time. Then it means that there will be more collision. Here is a graph trying to show you what will happen if you have a low concentration and what will happen if you have a high concentration. So number of particles, and then this is the kinetic energy, and then this is a number of particles which have more kinetic energy compared to activation energy. When you have a low concentration, the number of particles are fewer. Then it means that you have fewer particles which have kinetic energy greater than the activation energy. And then you see that here, if you draw a line here, you find out that if at a low concentration, the particles which have more kinetic energy compared to activation energy, they are fewer, if you draw a line here. But if you look at this, you'll find out that the particles which have kinetic energy here, they are more. Here, the particles are more than this. So it means that this reaction will have more particles which have kinetic energy compared to activation energy, and more reaction is going to take, or a high speed of rate is going to take place, or the rate at which this reaction is taking place is going to increase due to the number of particles which are reacting per unit time. So number of additional particles with energy greater than activation energy, therefore enough energy to react. So this one shows this line from here to here. It shows that how many particles have been added when you added you increase the concentration from this point to this point. So this graph shows that what is being added when the particles, the reacting particles, have been increased. Then concentration here is trying to show you exactly what happens in the reacting vessel. That concentration of the reactant increases the particles per unit volume, per unit. So it increases, the concentration increases the particles per unit volume. So if you have a low concentration, you have fewer particles. If you have a high concentration here, you have more particles. So you'll find out that more particles have a kinetic energy, have energy greater than the activation energy, because now there are so many particles in the reacting vessel. Then automatically it means that more collision is going to take place. If more collisions, more concentration, more collision takes place, and then what will happen? More reactants are going to be converted into products. So that's why it is called collision theory, that how is the collision leads to the reaction to take place. So if you increase the number of particles in a vessel, as long as you have not changed the volume of the vessel, then it means that the collision is going to take place, which is going to take place is going to be higher, so it's going to be greater, and then this results in the reaction taking place at higher rate. And then you're saying that since we have more particles with energy greater than the activation energy, more effective collision takes place per second, and then therefore the rate of reaction is going to increase. Fewer particles, it means that fewer collision. If you have a high concentration, it means that it's going to have more particles reacting, and then because of the more particles, then it means that more collision is going to take place, and then the rate of reaction is going to increase. And then another factor is adding a catalyst. So